Today we're working on a 2007 Mini Cooper with a 1.6 naturally aspirated engine. It's setting a cam sensor code. The code on the manufacturer specific side of things is 002983, and the description says inlet camshaft sensor. I want to show you why I don't usually, on European cars like BMW, Volkswagen, Audi, I don't really mess around with the manufacturer side of things unless it's absolutely necessary. And the reason for it is over here on this screen, I punch that code into the search function on ProDemand and nothing. There's no information for that code on ProDemand at all. And that can be frustrating and slow you way down, or make it so you can't diagnose this vehicle. So I'm going to show you how I do this, and if I'm willing to take on something like this, how I go about it. I knew nothing about this vehicle at 2 o'clock yesterday afternoon when I took it in. Everything I know about it, I learned in the last, 10 hours or so. So we're just going to go through it here. So back to the scan tool. I'm going to back out of the module. I'm actually going to forget the vehicle. Go all the way back to the main menu. And here you can see I already scanned it using generic OBD2. You can see that's this one here. It's eOBD on the Autel tool. So I'm going to scan it here again. Oh, I had to turn the car on. That's a good noise. We don't lose the scanner module. So like I said, I didn't know much about this yesterday. So, but I've got enough experience and a really solid understanding of the fundamentals and the engineering behind a lot of these vehicles. So I don't necessarily need to know what the exact design is until I'm start working on the car anyway. But that's why we're going to use the generic side of things. It is setting a P0342, and it's got a pending 0342 as well. And that gives you a little more information. Camshaft position sensor A, circuit low, bank 1, or single sensor. Doesn't tell you it's the intake side, so that can be a little confusing. But that's still enough information to get through this. We know there's 2 cam sensors on this engine, and I'm going to show you how I know that. So we're just going to back out of that for now. That's all the information I need from this vehicle. I'm going to go over to the laptop. So I'm going to pull up the wiring diagram. We're going to scroll down until we see the cam sensors. So this is says it's convertible. That's not the one we're looking at. This is a hard top. So this is the start of the accept convertible. We'll go down, see if we can find those cam sensors. So there's the intake camshaft sensor. It shows a yellow, an orange, and a white wire. And then there's the exhaust camshaft sensor that also yellow, orange, white wire. So what I'm going to do is, ProDemand actually makes this pretty nice. You can click on the wiring diagram, go right to the component, and sometimes, not always, but sometimes, it'll give you the component connector pin out, and that'll give you enough information here. So it shows one is ignition voltage on the orange, yellow is a cam sensor signal, and 3 is the DME ground, which is the engine controller on this vehicle. BMW calls them a DME. But that's actually wrong, unfortunately. It is not ignition voltage on the orange wire. It is 5 volts. So that's also important to understand once you look at the rest of the theory and operation. And that's what we're going to look at right now. So we're going to go down to component operation. And it's pretty generic, pretty worthless, really. It just basically says that it will set a code and it won't stop engine operation. You can read through that on your own time. Pretty worthless. But under the OEM testing, again, not super useful. It gives you a nice waveform, which is kind of cool, but doesn't tell you what the value should be or what size your square wave should be on the scale or anything like that. So again, not super useful to me, but in the guided component testing, if you go to the intake sensor, it actually says that there is a 5 volt, a sensor ground, and ignition power. So what I wanted to show you exactly, so it gives you the signature. And it says here, yellow, CMP reference, black is known good ground. It's saying yellow because it's set up for the snap-on scope. This is actually a snap-on guided component test. But if you look here, key on, engine off, with the connector disconnected, it says the sensor signal wire should have 12 volts present. That's important, and that information is missing pretty much everywhere else. But this will make more sense when we look at the waveform. So here is the waveform. I'm going to zoom in a little bit. And you can see the bottom is the intake camshaft sensor, and the top is the exhaust. The intake camshaft sensor is only creating a 2.5 volt square wave, and the exhaust is creating a 12 volt or ignition volt square wave, because obviously running is going to be over 12 volts there. So here's what the picoscope setup looks like. These are really easy to get to, which is pretty awesome. So I was able to just back probe each one, and they're actually the same part number, so if we wanted to, we could just swap them and see if the code moves, but this is more interesting and the right way, in my opinion. So again, without knowing much about this, the first thing I did was pulled the cam sensor code in the generic OBD, scoped both sensors, got this waveform, and then started analyzing them. So knowing that the exhaust one isn't setting a code, we can assume the red trace is normal. The blue trace is abnormal. What's weird is you have a 5 volt feed, a ground, and 12 volts. So not knowing that there was ignition switched voltage on the sensor wire, that's kind of confusing. But logic will tell you it's got to come from somewhere, and if it's not coming from the 5 volt feed, it must be coming from that other one. And you can confirm that on the signal wire using an amp clamp to determine the voltage is coming from, or the amperage in this case, or the voltage is coming from the PCM or DME and is going through that sensor to ground. So that could be confirmed with an amp clamp if you didn't want to rely solely on logic. But what's interesting is the 2.5 volts, the square wave on the intake sensor, the one that's set in the code. So what we did to confirm this was unplug it and see, according to the information, if it had 12 volts there, and it does. So we know that that sensor is actually pulling amperage on the signal wire all the time. Not, because the amperage should be near zero when the square wave is high at 12 volts. and the sensor is actually pulling that to 0 volts, so there's going to be amperage flowing on that wire as well as pulling the voltage to 0. So what's really cool about that is you could really verify these sensor operations if you had a known good and a bad one just by throwing an amp clamp on this. But it's kind of a weird failure, so I just wanted to highlight this and show you how I got through it. This diagnosis probably took about 20 minutes, half hour. But because of a solid process and understanding the fundamentals of what you're looking at. So I confirmed with the wiring diagrams and spent, I probably spent a total of an hour on this car after being fairly certain that the sensor was the problem. But that's how I got there. And that's why I use generic on a lot of European cars in general, and even modern cars. If I'm not really confident with the manufacturer side of things, I'll just punch in the OBD2 stuff. I've got all the data in there I need to diagnose a drivability issue, and it makes really quick work of things. So just kind of a neat one. You can see if you don't have your scaling right, you could even really mess with yourself. You can see if we adjust our scaling, I can make these look really similar. Like that. So, scaling's important. It's really important to understand what you're doing and why and what you're expecting to see. Then if you see something you don't expect to see, you have to just take the time and work through it logically and understand why that would happen. So I hope this helps somebody out. Back to the codes here. Wow. The original manufacturer code is at 2983. So again, Pro Demand and Mini and BMW and Volkswagen, they don't play nice with anybody. So a lot of times you're going to run into problems like this where the information is just not available. But again, if you have a good understanding of the fundamentals and there's only so many ways things can be designed, you can not very easily, but you can work your way through these problems, even not having as much information as you'd like, knowing there's only so many ways to make this work. So if we have a 3-wire sensor, chances are it's digital. Chances are it's got a feed, a ground, and a signal wire. There's a little bit of a variable added in with that 12-volt ignition switched feed on the signal wire. But really, that's brilliant in the engineering terms because it makes diagnosing this system super nice and easy if you know what you're doing. So again, the Germans make it easy. They just don't give you the information to make it easy for you. But that's how you get through this. So thanks for watching. Like and subscribe, please, if you like this, and I'll make some more.